Hey everyone, welcome back. This is our December holiday lesson. So it's not live, but hopefully you can still benefit and go through the video recording and then go through the questions that are on our whiteboard. So let's start by looking at our question. We're going to look at simultaneous equations again, but in this lesson, we're going to step it up a level and then also look at questions that involve word problems and how to arrange those word problems into simultaneous equations. So let's jump on to remind ourselves on how to solve simultaneous equations. So here is the method we were using in today's session. Now we've looked at graphical method 2-3 weeks ago now, and now we're looking at the elimination method. And so for elimination method, it's quite simple, right? We're going to first of all look at how to eliminate the unknowns. Now if we can eliminate unknowns straight away, that would be brilliant. And the way we do that is if we have the same coefficient, that would be perfect. Now, if we can't do that, we're going to look at how to do that in a minute or two. But first of all, eliminate the same coefficients, then solve the equation. And then once we've solved the equation for one variable, one unknown, then we can do the same thing by substitution and solve the second equation with the second unknown. So let's jump onto our iPad and see what that looks like in action. So here we know that we've got x plus 8y equals 26 and x plus y equals 5. That means that we've got the same coefficient for x. That means we've got 1 here and 1 here, 1x, right? And so that means for us that we can solve this simultaneous equation by eliminating x. Because they have the same coefficient, we can just subtract. We can do x take away x, just like column addition or subtraction. X take away x is 0x, so that's gone. 8y take away 1y is 7y. And then we've got 26 take away 5 is going to be 21. And so what we're saying here is that the difference between this line, right, this equation, and this equation is the fact that this one has got 7y fewer in the equation and it's got 21 fewer. So that must mean that the difference is 7y must be equal to 21, right? Because that's the difference between the equations. If 7y equals 21, then y must equal to 7 divided by 7 is 1y, and 21 divided by 7 is going to be 3. So therefore y is equal to 3. So we've got the first solution for our problem. Okay, so what did we say we need to do after that? We said after we solve the equation, so we've just solved the first equation here, 7y equals 21, and therefore y equals 3. After we've solved that equation, solve the equations, we're going to go to substitution. Okay, so what does that mean here? So we're going to substitute the y value into either of these equations. I'm going to choose this one. So I've got x plus y equals 5. Because I've just worked out what y is, I'm going to replace the y with 3, and so I've got x plus 3 equals 5, and therefore x must be equal to 2, right? Because if I subtract 3 on both sides, then I've got x is equal to 2, and that's our second solution. X equals 2 and y equals 3 is our final solution. X equals 2, y equals 3 is the solution we need for both of these simultaneous equations, right? We can test it out if we wanted to. So we can do 3 add 2 is 5. We've got that perfectly. And then we've got 2, because x is equal to 2. Add 8 lots of 3s. 8 times 3, 8, 16, 24. 24, add the 2, 26. Yes, it works perfectly. Now, we don't have to do that every single time. But if we wanted to, if we were unsure that if our answer was correct, we can always do that. Okay, so that's a simple one that we've looked at last lesson. Now, when it comes to a bit more complicated questions like this, we need to do one or two extra steps. So let's have a quick think about that. So we've substituted and we've solved the previous one. Now we've got this simultaneous equations we're going to look at. The first step it says here is to multiply, to create an extra equation or two, right, with the same coefficient. So here I could, if I had something that was a bit easier, I could just multiply one equation. So for example, if this was a 2 instead, right, if it's 2x plus 3y, then I could just multiply this equation, the whole thing, by 3, and then I'll have 6x. But I don't have that luxury, unfortunately, because it says that it's 4x here, okay? So that means for us, all right, it means we need to multiply both of these equations. I was trying to show you that if I multiplied, if this was a 2 x and I multiply this by 3, then it would be easy for us. But we can't do that because it's not a 2, right? So how do I do this? I've got a 4x plus 3y equals 9, and I've got 6x equal to 2y equals 33. So in this case, I'm going to have to multiply both of these equations. Now, I could multiply to get rid of the y or x. I'm going to choose the y in this case because I've got 2 and 3 here. So if I multiply this equation, the first equation, so I'm going to call this equation 1, and this equation 2. So if I multiply equation 1 by 3, what do I get? I get 6 times 3 is 18x. 6x times 3 is 18x. 2y times 3 is going to be 6y, and it's subtraction here. And then I've got 33 times 3, which is going to be 99. Perfect, 99. And then I'm going to do this. I'm going to get equation 2, which is this one, and I'm going to multiply that by 2. So I get 8x, because 4x times 2 is 8x. 3y times 2 is going to be 6y. And so I've got 6y plus 8x equals 9 times 2 is 18. And so I get 8x plus 6y is equal to 18. Okay, so far so good. Right, now that I've got these two, I'm going to call this equation 3 and equation 4. Okay, I'm going to get equation 3 and 4, and I'm going to subtract, right, or add. What should I do? I've got a negative 6y, and I've got positive 6y. So if I want to eliminate, so the goal, remember, is to eliminate. So have a look at this. Step 1, multiply to create an extra equation or 2 with the same coefficient. We've got the same coefficient, which is 6y. One's negative, one's positive, but they're both 6y's. And then it says to eliminate the unknowns. Now, when we've got 2 unknowns, x and y here, but the y has got the 6 in front of it, right? The coefficient of y is 6, but one is positive 6 and one is negative 6. In this situation, we're going to add them together because 6y add negative 6y is going to be 0. That eliminates it, right? Or negative 6y add 6y is going to be 0, right? Negative 6 add 6 is 0. And so because I'm adding these two together, I'm going to add 3 to 4. I'm going to eliminate the y's. So I'm left with 18 add 8 is going to be 26x. 26x is equal to 99 add 18 is 117. 26x is equal to 117. What's the next step? The next step is to work out x. So we're going to solve. We've subtracted, we've eliminated, right? So that was step 2, wasn't it? We've eliminated the unknown, step 2. Step 3 is to solve the equation. Okay, so solving the equation, 26x equals 17. Well, what do I get here? X must be 117 divided by 26. 117 divided by 26. 26 times 4, 25 times 4 is 100. So 26 times 4 is 104. So that's going to be 104. That's going to be 4 wholes. And 104 to 117 is going to be 13. After the 26, and so 13 26 is a half, so it's going to be 4 and a half, so 4.5. Okay, so x is equal to 4.5. We've got our first part of our equation solved, which is x. And the next step, once we've got x, we know it's going to be the same as before, which is to substitute. So let's substitute in the value here. So x equals 4.5. So I'm going to substitute 4.5 into one of these. I might use this one. So I've got 4x plus 3y equals 9. I've just worked out that x equals to 4.5. So I'm going to put that in there. And what do I get? I get 4 times 4.5 plus 3y equals 9. 4 times 4 is 16. 4 times a half is 2. So that's 18 plus 3y equals 9. So I can rewrite that. Let me get rid of this. So I've got 18 plus 3y equals 9. And so 3y must be, if I take away 18 on both sides, 3y must be negative 9. Is that right? 9 take away 9 is 0. Take away another 9 because 9 of 9 is 18. And so it'd be negative 9. 3y is equal to negative 9. And therefore y must equal to negative 3, right? Negative 9 divided by 3 is negative 3. So I've got y equals negative 3 and x equals 4.5 as my solutions to this problem. Right, so does that make sense? Can we do that for our questions on our whiteboard? Have I got the questions on the whiteboard that are there for you to solve, similar to these? And then we can also have a look at word problems that involve simultaneous equations. Okay, so let's look at the next question. It says a cinema ticket or cinema sells adult tickets and child tickets. The total cost of 3 adult tickets, so let's highlight some of this. 3 adult tickets and 1 child ticket is £30, and 1 adult ticket and 3 child tickets is £22. Work out the cost of an adult and a child. Work out the cost of an adult ticket and the cost of a child ticket. So okay, so we basically have to work out the cost of both of them. So because they've given us a word problem, we're just going to use the first letters, the initials of the key parts here. So adult, A for adult tickets and C for child tickets. So I know 3A, 3 adult tickets plus 1 child, which is just C, 1C, is equal to £30. And what else does it say? 1 adult and 3 children tickets or child tickets is £22. So I've just formulated my 2 equations. Does that make sense how I did that? Let me know if you're not sure how I got about doing that. So here they are. 3A plus C equals 30, which is equation 1, and equation 2 is 1A, or just A, plus 3C is equal to 22. How am I going to do this? Well, the first key step here is we want to make them have the same coefficient. Do I have to multiply both of these? No, because I can multiply the second one, for example, by 3, or I can multiply the first one by 3. Because then I'll have 3C. If I multiply the second one by 3, I'll have 3A. So in fact, for this one, I'm going to multiply the second equation by 3. And what I get is 3A plus 9C is equal to 20 times 3 is 60, 2 times 3 is 6, is 66. So I've got 3A, this is equation 3, 3A plus 9C is equal to 66. So can you see the next step? Let me write it down on the side, it'd be better. So I've got equation 3, which is 3A plus 9C equals 66. Equation 1, which is 3A plus C equals 30. And we can see that the difference between the two is going to be, well, if we just look at the left hand side, they both have 3A's. The difference is going to be this extra 8C for the third one. So what I'm going to do is, I can see 3 is 66 as well. It ends with 66. So I'm going to do equation 3 take away equation 1. So I get 3A take away 3A, which is 0. 9C take away C, which is going to be 8C. And I've got 66 take away 30, which is going to be 36, right? So 66 take away 30 is 36, yeah. Okay, so what's the next step? Then I've got 8C equals 66. So 8 children tickets is 36 pounds, excuse me. And so therefore, 1 child ticket must be 36 divided by 8. 36 divided by 8, 8, 16, 24, 32 is going to be 4. 32 to 36 is 4 remaining out of the 8. 4 over 8 is a half. So child ticket is £4, £4.5, or £4.50p. Right? So £4.50 is how much the child ticket is. So now I'm just going to substitute the £4.50 into equation 1. Equation 1 says 3A plus C equals 30. So if C is £4.50, if a child ticket is £4.50, then we can say 3A plus £4.50 equals £30. And therefore 3A is equal to £25.50p, right? If I take away the £4.50 on both sides, I get, well, 30 take away £4, £26, take away 50p is £25.50. So A must be £25.50p, £25.50 over 3. I can use bus stop method. 25 50 divided by 3, 2 tens divided by 3 is 0, 25 divided by 3, 8, 16, 24 is going to be 4 with 1 remainder, 15 divided by 3 is going to be 5, and 0 divided by 3 is 0. Oh, the adult tickets are also £4.50. Is that right? 25 divided by 5 is £4.50. No, what have I done? I've written 4 here. It should be 8, right? 25 divided by 25 divided by 3, sorry, is 8. 8, 16, 24. And therefore, I've got 1 remainder. 15 divided by 3 is going to be 5, and therefore it's £8.50. So £8.50 is the adult ticket, and child ticket is £4.50. Okay, so just make sure you don't make a mistake like I did there with the bus stop method, but we can see how to solve these word problems that have simultaneous equations in them by first formulating the simultaneous equations. Have a go at the questions on the whiteboard, and I'll see you next week. Bye.